Hi, everybody. This is Stats Class Section 3.3, Measures of Position. Um, and if you look at the first thing, we talk about measures of position and z-score. So I'm going to scroll up in the workbook back to 3.3 and just want to show you the normal curve, because when we talk about z values, z values have to do with normal distribution and the normal curve. The center, if you look right here, this symbol is the mean. And the z value at the mean is 0. And then this is one standard deviation away from the mean. We call that a z value of 1. Here, right here is 2 standard deviations away from the mean. That's a z of 2, and this is a z of 3. On the other side, 1 standard deviation to the left of the mean is a negative z value, z negative 1, z negative 2, and z negative 3. So a z value means how far away in standard deviations are you away from the mean. Right there is one, a z of 1 is 1 standard deviation away from the mean. A z of 1 this way to the left is negative 1. You're still 1 standard deviation away from the mean. So just to give you a little bit about z-score. Z-score is a z is actually how many standard deviations away from the mean are you. A positive means you're to the right of the mean. A negative z-score means you're to the left of the mean. All right, so in 3.3, we give us 2 formulas for standard deviation. It's the same formula. One's just sample, one's population. This is the x value. So we call this just the value away from the mean where you're at compared to the mean. This is the mean. Don't forget, that's the average value. That's the center. And this is the standard deviation. And this is all the symbols for population. Population mean, for sample. Sample mean, sample standard deviation. Over here, we still have the value. X is the value, but this is the population mean. You see there, but this is sample mean, this is population mean, and this is population standard deviation. And this is sample standard deviation. All right, so it's the same formula to calculate Z. It just depends on if you're using sample or population for which symbols you're using in the actual formula. So here's an example, and a student scores 65 on a calculus test. So that's not the average, that's just a score. So that's the value, x equals 65. Do you see? That's the value that we're comparing to the mean. In this problem, it says the mean is 50. And the standard deviation is 10. Okay, and then they give us some more, but let's write all this down over here. We have a score of 65. We have a mean. Let's do sample, mean, x bar. I guess I could clean that up a little bit. We have a mean of 50, and we have a sample standard deviation of 10. That's for test number 1. And then she said she scored 30 on a history test. So the first test was calculus, math, and this one is history. She scored a 30 on our history test. The mean is 25 and the standard deviation. Mean was 25 and the standard deviation was 5. And it says compare the positions of the test. In other words, find the z values. So once again, z value equals x minus x bar over s. So the z value over here, x was 65, the value. The mean was 50, and s was 10. When I put this in my calculator, I get 1.5. Over here, z equals x was 30, average, the mean was 25, and the standard deviation is 5. When I put that into my calculator, I get a z value of 1. So if we look at a normal curve, once again, this is a z value of 0. The mean, right down the center of a normal curve that has a z value of 0. This z value is 1.5. It's positive 1.5. So it's to the right of the mean. And this z value is 1. It's to the right of the mean also, but it's not as far as 1.5. So you can see the difference. This is history, and this is math. And if, the one farthest to the right is a higher score, is a higher overall score if you look at that. You can't go by the scores. You got to go look at the mean and all the, well, the highest position relative to the class. Let's put it that way. This Z value said you did better relative to the class than you did this one because it's further to the right. Okay. And which indicated has the highest relative position. That means which is farthest to the right. I don't know if we want to do them all. Well, here's the score. That's the X. You just put in your calculator, right? Don't forget the formula is X minus the mean divided by the standard deviation. So for the first one, 2.9 minus 4.2 divided by 1.3. Mm-hmm. And we get a z value. I should have just saw that. We get a z value that equals -1. I'm going to do one more. Let's do this one and just compare these two. A score of 620. The mean was 820 divided by 220. 620 minus 820 divided by 220. And I get a z value of -0.9. So when we look at this on a normal curve, this is z of 0. A -1 would be here, but a -0.9 is here. So which has the higher the highest relative position. The highest relative position is farthest to the right. So that would be the answer. I didn't calculate this one. But if you compare two and they're both negative, always the highest, the best relative position, the highest is the one which is furthest to the right. And they just show you different ways of manipulating the Z formula and everything. I wouldn't worry about that too much. But there are going to be problems that look like this one. The average salary for a teacher is this. So that's the average, the mean, 54,156. Standard deviation, 10, 420. Find the salaries that correspond to the Z-score. So they tell us the Z-score, we have to find the salary. Do you see I have the mean, I have the standard deviation, and I have the Z. I need to find the X value. Don't forget, the formula is Z equals X, this value minus the mean over standard deviation. So if we know Z is 2, we're trying to find the X value. The mean was 54,156, and the standard deviation was 10,420. Okay, so we're trying to find this X value. So we have to use a little bit of algebra here. So it's going to be the same process. You always want to get rid of this bottom first. It's divided by 10,420. So I'm going to multiply both sides by 10,420. Multiply this side by 10,420. These end up canceling, those two. One's on top and one's on the bottom. So on the right-hand side, this is what I get. On the left-hand side, 10,420 times 2 is 20,000. 2,420. I didn't write that down. There we go. Is 10,840. So the last thing we want to do is bring the minus 5 over to the other side. We want to get X by itself. We're going to add, it's a subtract 54156. You always do the opposite. So we're going to add 154 or 54156. That turns to 0. I'm left with X equals, and then we're going to add these up together. 74. I hope I added it up correctly. So the teacher's salary that compares to that is at a 2Z value is 74,996. And once again, looking at a normal curve here, this is the mean. The average teacher salary is 54,156. 70,000 is some over here. Do you see two Z values? Two Z values. But look, on a negative Z value, if the average is 54,000, a negative Z value is less than 54,000. So let's do this next one that's less. So we should get less than 54,000 because Z values to the left are less. Once again, the formula Z equals X minus X bar over S. The Z now is -2. X is what we're looking for. The average was up here, 54,156. And the standard deviation was 10,420. Get the 10,420 to the other side by multiplying it. It's dividing, so I need to get it 10,420 multiplied by 10,420. One on the bottom and one on the top cancels. And on this side, I get a -2840. 10,420 times negative 2 is 20,840. Get the 54156 to the other side by adding 54156, adding 54156. Negative 20840 plus 54156. And a teacher with a z-score of negative 2 gets 33,316. So you saw the difference. This guy got 70-some thousand. This person got 33,000. A z-score of 0. Remember, a z-score of 0 is the average. 54156. A z-score of 0 is the average. The average is right here. This is the average. It's also a z-score of 0. So a z-score of 0 is whatever the mean is. All righty. Okay, so we have another form of measure of position, percentiles. If you've taken the SAT, they tell you you're in the 90th percentile. 90th percentile means you did better than 90% of everybody else. You're in the top 10%. So if you're in the 50th percentile, half the people did worse than you, half the people did better. You're right there in the middle. Percentiles are go to 100, 100%. Here is the formula. So this is one of those you definitely want to write down. Have in your formula sheet that you need. Percentile is the number of values below X plus 0.5 divided by the total number of values times 100. And we'll do an example of that here in a second. So that is the formula for percentile. And I'm going to leave it here. Just scroll up a little bit. So a teacher gives a 20-point test to 10 students. Find the percentile rank of a score. So these are 10 student scores, and 12 is your percentile, is your score. You want to know, are you better than 50% of the students or worse, or where do you fit in compared to everybody else? Well, the easiest way to do this, first of all, is put these scores in order, 2, 3, 5. If I can put it in the correct order. 2, 3, 5, 6, 8, 10. 12, 15, 18, and 20. There should be 10 scores here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we want to find the percentile for 12. Well, percentile equals the number of values below 12. Do you see below X? 12 is our X. There are 1, 2, 3, 4, 5, 6. 6 scores below 12. So our percentile is the number of scores below 12, and there are 6. And then we have to add 0.5 to it and divide by the total number of values. There are 10 values. There are 10 values here. So we divide by 10 when we put this in our, and then multiply by 100, by the way. And that's our percentile. So when we put this in our calculator, we get 65%. You just add the percent symbol at the end. You get 65 and then add the percent symbol. So if you scored 12 on that test compared to everybody else, you were in the top 65%, or you were better than 65% of the students. 35% did better than you. It's a good little formula to have. Find the percentile for the score of 6. So we're going to do now the next, is it the same data? I'm assuming it's the same data, yeah. So now we're going to do this one down here for a score of 6. There were 10 total. We're going to add 0.5, multiply by 100, a score of 6. There were 1, 2, 3 scores below 6. There was 3 numbers below 6. That was it, yes. And when I put this into my calculator, 3 plus 0.5 divided by 10 times 100, I'm in the 35 percentile. In other words, I did better than 35% of the class, but 65% did better than I did. So this was the answer for that problem down there. Let's try this problem. The average weekly earnings of the dollar listed. Find the percentile rank for each value. Round to the nearest whole percentage. So if we do 635, how many numbers were less than 635? I can't even see because I covered that up. There we go. There's only one number less than 635. One is less, add the 0.5, divided by 1, 2, 3, 4, 5. Do you see there's only 5 data points times 100? And on my calculator, 1.5 divided by 5 times 100, I get 30%. Okay. That's not too bad of a formula. Finding a data value corresponding to the given percentile. So now we're going to find the actual data value, the score that we need to get to a certain percentile. We have to use a different formula. So once again, n is the total number of values. If we had 10 items, then n would be 10. If we had 5 items, n would be 5. P is the percentile. C is the score that we're looking for. Now, there's a little trick here. You got to be careful. Let's read these steps. When you do this problem, make sure you read these steps. If C is not a whole number, round it up to the next whole number. So it automatically, even if it was, let's say the score was 12.1, it automatically goes up to the next whole number. That's what it says. No matter, we're not rounding it according to looking at the decimal. If there's any piece of decimal, it goes up to the next whole number. If I had 17.0001, it goes up to 18. If there's any decimal, it goes up to the next whole number. That's called rounding up to the next whole number. If C is a whole number, then use the halfway point between the C and the C plus 1 values when counting up from the lowest value. So we'll have to do an example to see what that means here. Okay. So let's take a look. It's always, sometimes the wording isn't always that great. Well, they did the work for us. Look at this. So a teacher gives a 20-point test. There's 10 students. So that's n. N equals 10. Find the value that corresponds. Which of these values is the 25th percentile? The formula is here. Do you see P, 25th percentile? N, there's 10 students. We put this in our calculator and we get 2.5. 3a says if C is not a whole number, round it up to the next whole number. And 3, that's our third value. So 3 means our third value. Do you see, where does it say? It doesn't, does it tell us that up here? It should. And arranging the, find the percentile. It doesn't say, we should say what number of value in our data. We should say something like that. What number value in our data? When it's in order from lowest to highest. So we got 3 and they got 3. So if you have the data in order, here's our data, we put it in order. Our third value is right here. We already said that 5 is the 25th percentile. C is the third data in order. Third piece of data. And so this is the third piece of data. The answer is 5. 5 is our 25th percentile. Okay. So that's if we had a decimal, you round it always up to the next whole number. Never round these down. For this problem, you always round up. In the next problem, here's our data. We put it in order. We want to find the 60th percentile. Percentile is 60. And there's 10 pieces of data. We get 6. Now remember what it said when you got 6. Since C is a whole number, because you didn't get a decimal, we got a whole number. So we go between C and C plus 1. Well, C is 6. You see, C is 6. 6 plus 1 is 7. So our answer is between the 6th and 7th piece of data. The answer is between these two. 1, 2, 3, 4, 5, 6, and 7. So we want to, what's between the average of those two? 10 plus 12 divided by 2 is 11. So our answer for the 60th percentile is the number 11. You see, since it doesn't end up to be a decimal, a whole number, you have to pick the 6th and one more 7th. The 6th and 7th, and find the average of those two. The scoring average was 11, so 11 is the 60th percentile. And when you do these percentiles and you're actually calculating what we just did, the number, not the percentile was easy. We just put it in the calculator. Here you had to follow these rules, so make sure you follow the rules. If C is not a whole number, if it's a decimal, You always round it up to the next whole number. If C is a whole number, then you go between the 6th and the 7th, or if we ended up with 8 and the 9th, always the seat and the seat plus 1. Okay. We're going to talk about quartiles. Quartiles, quarters, broken into 4 parts. Okay. There's Q1, Q2, Q3. When we have this, things are broken into 4 parts. If I could, do you see how we have 4 parts here? We call this Q1, Q2, Q3. This is the spot that stops Q1. This is Q2, Q3. Find Q1, Q2 from this data set. I'm going to use the calculator here in a second, but they don't tell us much about this. I guess they want me to just show you on the calculator, so let's do that now. All right, so we are going to find Q1, Q2, Q3 on the calculator. Okay, so here's our data. I'm going to read, here's our data. And don't forget this number 18. I'm just going to bring it over here, 18. There you go. I just took this data and put it right there. So there's our data. Let's put all this data into L1 of our calculator, into list 1. Stat number 1, edit. Clear your list 1 that you had. 15, 13, 6, 5, 12, 50, 22, and 18. 15, 13, 6, 5, 12, 50, 22, and 18. So there are 8 pieces of data there. 1, 2, 3, 4, 5, 6, 7, 8. 8 pieces of data. And let me show you how we're going to find Q1, Q2, and Q3. By the way, we already know how to do it. I'm just going to remind you. All righty, so I put the data in a calculator. To find Q1, Q2 through Q3, we just do what we know. Stat, arrow over to calculate, 1 var stats, and hit enter. Just like we're finding the mean. We're finding all the data in list 1. Hit calculate, and look, there's the mean. There were 8 pieces of data. There's the standard deviation. There's the population standard deviation. Okay, we want to find Q1, Q2, and Q3. From here, we just scroll down. Q1 is 9. Q3 is 20. And the median is called Q2. So Q1, Q2, Q3. The median is the number in the middle. So there's Q1, Q2, Q3, 9, 14, and 20. And do you see the smallest piece of data, the minimum piece of data was 5, the largest piece of data was 50. There's Q1, Q2, and Q3. So how did we get that? We typed our data into L1, then we went to stat, arrow over to calculate, number 1 var stats, just how we find mean and standard deviation. Hit enter, make sure there's nothing in the frequency list because we're only getting our data from L1. Hit calculate and scroll down. Q1, Q2, and Q3. Median is Q2. You might want to make a mental note of that or actual note on that. So Q1, Q2, and Q3. Looking at my calculator again, Q1 was 9. Q2 median was 14. And Q3 was 20. Now, there's something else that we're going to learn about the interquartile range. The interquartile range, by the way, we're going to be looking at box plots. I think we're going to be looking at box plots tomorrow. When we do a box plot, this is Q1, this is Q2, the median, and this is Q3. Do you see there's 1, 2, 3, 4 sections here. First quartile, second quartile, third quartile, fourth quartile, but we call this Q1, Q2, the median, and Q3. These are specific spots. And remember, if you looked at our calculator, our minimum piece of data was 50. I mean, 5. 5 was our smallest piece of data, and 50 was our largest piece of data. So this little spot is the minimum. This spot is the maximum. This is Q1. This is the median, Q2, and this is Q3. So we can get all that from our calculator just by putting the data into L1. And we're going to deal with that a little bit more, the interquartile range and everything. So let's find the interquartile range of this data set. In other words, we need to find Q3 and Q1 and subtract the 2. So first step 1 is type all this data into L1. Oh, it's the same data. It's the same data, right? Okay, so we already, well, what did we get? Yeah, it's the same data. 15th, yeah, it's the same data. Okay, stat calculate number 1. And then we scroll down. So Q3 minus Q1. Q3 on my calculator was 20. And Q1 was 9. So the interquartile range, 20 minus 9 is 11. IQR, interquartile range, is 11. Don't forget, Q1 was 9. Q3 was 20. 20 minus 9 is 11. It's our interquartile range. Now, there's something in data called outliers. Outliers, and by the way, if you're watching news and all this, especially during these political, this political time and everything, they get a lot of polls and news. They talk about outliers and things like that, interquartile, maybe not interquartile range, but they'll talk about the mean and the median and different pieces things you can do with the data. But we do need this formula to find outliers. Outliers are extremely high or low pieces of data that don't fit in. You know, let's say I was measuring people's heights at St. Philip's. There was somebody that was 4 foot 6 inches, 5 foot 2 inches, 6 foot 0 inches, 5 foot 9 inches, 6 foot 3 inches, 4 foot 11 inches, 9 foot 5 inches. Well, if you look at this, this might be a piece of data that doesn't fit. There might be something wrong. I've never seen anybody that was 9 feet tall. Sometimes when we type in data, we type wrong things in. So using this outlier formula, sometimes we're able to find data that we just typed in wrong, where it shouldn't be there. Sometimes it should be there. It's just a freak accident. This person, 9 foot tall person, was a freak. That's kind of a bad word. But it doesn't fit. The data doesn't fit what we see as normal. It's not, you know, an outlier is something that is way, way out there. Well, to find outliers, you do Q1 minus 1.5 times the IQR. That's the low outlier. To find the high outlier, we do Q3 plus 1.5 times the IQR. So this is really important to write down, the low outlier and the high outlier. Okay, so we're going to try this out now. Check this data for outliers. So the formula for outliers, once again, it's the same data we just had. It was Q1 minus 1.5 times the IQR. And then it was Q3 plus 1.5 times the IQR. So we're going to, even though we have all this data, I'm going to put all this into L1. And I need Q1, Q3, and I need the IQR. IQR, remember, was Q3 minus Q1. So we have this data in our calculator already. It's the same stuff we were just using. Q3 was 20. Q1 was 9. So the IQR is 11. 20 minus 9 is 11. So 11 goes into this spot. Multiply it by 1.5. Q1 was 9. Q1 was 9. And Q3 was 20 plus 1.5 IQR. So I'm going to put this into my calculator. 9 minus 1.5 times 11. And I get negative 7.5. Then when I put the other one in my calculator, 20 plus 1.5 times 11, I get 36.5. So this is the low end, and this is the high end. Is there any piece of data smaller than this? No, there's no negatives. So there is no low outlier. Now the high, is there any piece of data higher than this? And there is one piece of data higher than 36, number 50. So 50 is an outlier. It's a high outlier, but we just say it's an outlier. 50 is a piece of data that probably doesn't fit. It might be a freak accident, but it probably doesn't fit. What was it? question again? What did they talk about? So it was no real life situation, right? So I was just looking and see if it was. No, so we could say we could look at the real life situation and see if 50 matches, but it didn't. So that's how you do that. You have your data, you put it in L1, you find Q3, Q1, and you put them into the formulas like we just did. If there's any piece of data lower than the low part, then it's called an outlier. If there's any piece of data higher than the high number we get, then it's called an outlier. The only piece of data that was higher or lower than the numbers that we created was 50. So 50 is an outlier. It's a piece of data that probably doesn't fit into here. There might be something wrong with it. It just gives people an alert to say, hey, take a look at this data a little closer to see if that works out or not. So there's a lot of formulas we have in 3.3. We're going to talk more about this IQR and Q1, Q3 in section 3.4. But before you do that, make sure you have all these formulas down that we've talked about. You guys have a good day.